Okay, so today we're going to learn how do you solve other types of triangles. So solving means finding all missing angles, all missing sides. So like in this example, this is not a right triangle. There is no 90-degree angle. So what do? And there's actually a formula. There's two formulas we could use. One is called the law of sines, which says if you take the sine of A and the side across from it, that equals the sine of the angle B divided by the side across from that equals the sine of angle C divided by the side across from angle C. So there's one formula to use. And then there's another formula that we could also use, and it's very similar to Pythagorean Theorem. There's three of them. And basically a squared plus b squared equals c squared, but you also have to take off a 2ab cosine of c. Now notice there are no right angles. So why have two different laws? They're called laws because sometimes you need to use this formula, law of cosines. Sometimes you need to use the other formula, law of sines. So I'm going to spend today going over just law of sines for the most part. So here's what's going on. Let's say you take it, we're going to do law of sines first. Say you take a triangle. That's not right. And I know all sides look the same, but maybe they are, maybe they're not. But regardless, no angle is clearly 90 degrees. They're all acute. Now let's label. Remember, if we let this be big A, then this is little a. If we let this be big B, then this, if I let that be big C, that's little c. So can I use SOHCAHTOA on this? The answer is no. Because this is not a right triangle. But could I make this triangle into a right triangle? This. Draw a line straight up and down. Now I have two right triangles. So by doing this on purpose, I get this is 90 degrees, so I can use SOHCAHTOA, and that's 90 degrees, so I can use SOHCAHTOA. And most people like to call up and down height, so I'm going to put that as h. So let's see. Basically what I'm going to show you is how to get the formula, and once I show you how to get the formula, we're just going to use the formula. So let's start off with A. What is the sine of A? What's the sine of A? Reference angle, sine, opposite, hypotenuse. What would the ratio be? H over B, right? Now, what would the sine of B be? So over H, H over A. Now, this is kind of like systems of equations. We have this equation, this equation. Besides sine, what do they have in common? This one has an H and HA. They both have H. So what if I solve them both for H? So if I multiply both sides by B, I get B times the sine of A equals H. And then over here I'd have, if I multiply both sides by A, I'd get A times the sine of B equals H. Now, if they both equal H, If this equals h and that equals h, then these must be equal because h equals h, so these must also be equal. So now I could put the formula b times sine of a equals a times sine of b. If they both equal h, then they both equal each other. This is called a proof, by the way, when you're proving something. Next, let's divide both sides by AB, which is it's a property of, you can divide both sides by whatever you want. The B, and I get sine of A equals, here, these A's cancel, and I get sine of B over B. And then if you did this exact same thing, and you did sine of C is, and you drew the triangle a different way, you would get also the same thing. You'd get sine of C over little c. That's where that formula comes from, and we're just going to use it. We're not going to prove it every time. I just wanted you to see that I'm not just making up a formula. It came from what we've been learning. So this is what's most important. This is called the law of sines. Now, there's two laws. The other one is called law of cosines. And it also has a proof, and I don't want to spend, it's just way too much information to go over both, so I'm going to actually save this. Thank you. I'm going to save this for another day. I might do the proof. You guys want to see the proof now ahead? Sure? So I'll talk about them both, but all of the problems today will focus on law of sines. Okay? So law of cosines. Let's draw that triangle we had up here. So, I'm going to draw me a triangle. I'm going to keep them the same, a, little a. It doesn't have to be this way, it just makes it easier. And we're going to do the same thing we did earlier. We're going to, this is not a right triangle. We can't use Sophotilla, so we're going to make it into two right triangles. And then make it even further. This whole thing is C, right? Let's let this be X. So from here to here is X. YX, we just chose a random variable. But C to B, well, if this is X and the whole thing is C, we don't want to create too many variables. So let's just do this as C minus X over here. And remember we did some practice with this earlier in the class a few weeks ago to get that. So what I see now is, and we'll let this be H again. So I created two variables, X and H. We don't want a formula that has an H. We want a formula that only has capital A's, capital B's, capital C's, lowercase a, lowercase b, lowercase c. So first, I have two formulas I could put down. One, notice I can use Sophotilla, or not Sophotilla, but Pythagorean Theorem, that says if you take c minus x squared and you add on h squared, you get a squared. Do you agree with me? Pythagorean Theorem, the sum of the two legs squared equals hypotenuse squared. Now if you take c minus x times c minus x, you take c times c, you get c squared. C times negative cx. Then you take negative x times c, you get negative cx, making negative 2cx. And then negative x times x plus x squared. Bring down what we have. I know I made kind of a big jump right there distributing. Do you guys understand how I distributed? We write c minus x twice, and go c times negative x times c, negative x times negative x. I just did that in my head to save space. Alright, now on the other one, couldn't I put x squared plus h squared is b squared? Pythagorean theorem. So x squared plus h squared is b squared. I could say that. And then, notice right here, I have x squared plus h squared. I'm trying to get rid of all the x's and h's. So let's put, instead of x squared plus h squared, this doesn't look like an h, I apologize. Instead of x squared plus h squared, let's put a b squared. Nice, we got rid of the x and the h, almost. We still have this x I want to get rid of, and once we get rid of that x, I'll be happy. Because we want our formula to only have capital A, capital C, lowercase a, lowercase b, lowercase c. Because we don't have to draw right triangles all the time. Now let's go back, cosines. So you could try sine, you could try cosine, you could try tangent, but I'm telling you the way it works is let's take the cosine of A. What's the cosine of A? Adjacent over hypotenuse. Adjacent is x. Hypotenuse is b, right? Cut, CAH, adjacent over hypotenuse, x over b. And remember, my ultimate goal is to get rid of x. So I'm going to solve this for x, and I get b times the cosine of A equals x. So right here, instead of putting x, I'm going to put b times cosine of A. You may not understand all of this proof, and it's fine. I just want you to know how to use it. So if you're sitting there going, what? It's okay. I feel like I owe it to you to show you the proof. I'm going to rewrite this so it just makes it look nicer. So I'm going to put the a squared first. And then see how I have c squared minus all of this plus b squared. I'm going to put the b squared third. I'm just putting it in an order that makes more sense to me. So I just put these two together. And then here, instead of 2cb, I'm going to put 2bc just because we like alphabetical order. So we just made a formula that only has capital A's, capital B's, capital C's, lowercase a, lowercase b, lowercase c. If you want to find the side that's across from angle A, and you square it, and you take the side across from angle B, and you square that, you take the side across from angle C, you square that, and you take away 2 times the side B times the side C, and then you multiply the cosine of A. And if I did this 3 more times, you would also find other formulas. You would find that B squared equals A squared plus C squared minus 2AC times cosine, what do you think the end is going to be? Yeah, cosine of angle B. If I did all of this work again, and I just changed the letters, I would get that. And then what do you think C squared equals? This one was A, and then you use B and C. This had B, so you use A and C. This one's C, so what letters would you use? A and B, right? And then notice the formula used BC and used AC. And this one's going to be AB, right? And instead of cosine of B, it's going to be cosine of C. Pretty cool, I think. So again, today we're just going to focus on law of sines, which I just highlighted, law of cosines. So when do you use both? When to use when? Well, the law of sides we're going to use this. We're going to use when you know A and little a, or B and little b, or big C and little c. In other words, you know the angle A and the side across from it. Or you know angle B and the side across from it. So if you're looking at a triangle and you see an angle with the side across from it, you're going to use law of sines. And then law of cosines, you're going to use when you have basically when you have this, when you have a triangle and you know the side, the angle, and the side. So when you have an angle included between two sides, that's when you're going to use it. And if you know all three sides and no angles. You may want to just get in. You're looking for, basically, if you see this, if you see that, you're going to use law of sines because you have the angle and the side opposite it. Does that make sense? You're going to use law of sines. Otherwise, you're probably going to use law of cosines. Law of sines is way easier to use. So if you know an angle and a side opposite it, you're good. However, to solve these, you need 3 pieces of information. This one only had 2, so you'd have to give me like another piece of information somewhere, either an angle or a side. But to use law of sines, you need an angle and a side across from it. So what I first want to do, we're not doing all these examples. And I like to start with one with the pictures first. Makes it easier. Determine which one we're going to use. So 4 is a side. I know 7 is a side. I know 5 is a side. Which one are we going to use when you know all 3 sides? Yeah, law of cosines, which we're not going to solve any law of cosines today, just sines. So we're going to use law of cosines because you have all 3 sides. In order to use law of sines, you have to know at least one angle. If they told me what this angle was, I could use law of sines, but they didn't. So I have to use law of cosines. Number 6, what do you think you're going to use? Law of sines, good. I have the angle and the side across from it, and then one more piece of information. So I'm going to use law of sines. In a second. Probably the hardest part of this is trying to figure out what to use. So we'll solve that. What about number 7? Law of sines, because I know the angle and the side across from it. And then one more piece of information. So I'm going to say law of sines. Number 8. I know an angle, but I don't know what the side is across from it. This is called side angle side. Side angle side. It's when the angle is included between 2 sides you know. And I believe that's how we wrote it on the back. When we know this, side angle side, we use law of cosines. Good. And we're not going to solve that today. They didn't draw a picture, but it's all A, B's, and C's. Okay, so don't make this hard. Just draw yourself a triangle. So draw yourself a triangle, and it doesn't matter. I'll put it over here just like you did. It doesn't really matter how you draw it. You're just drawing a triangle. Enough information to really know. And then you decide where you want A, B, and C to be. It doesn't matter. Because no matter where you put it, you can just rotate the triangle to make it look the way you want it to look later. So in my proof, I made this be A. So I'll just keep with it. A. And in my proof, I made this be B. So but again, it doesn't matter. And we'll let that be C. And then fill in what you know. Measure of angle A is 72 degrees. Where does that go? Right here, right? Little a is 21. Well, little a is across from big A, right? So this is 21. And then B is 17. Little b is the side across from angle B, so this is 17. So which one am I going to use? Law of sines, good. Because I know an angle and a side. My pen was not quite dry yet. So yeah, I'm going to use law of sines. Next one. Again, I mean, if you want to just draw your triangle like that every single time, doesn't matter. Big A. If you want to put B up there, you can. I'm just going to stick with what we've been doing. So little a is 2. So little a would be across from angle A, so this is 2. Little b would be across from angle B, so this is 5. And little c is across from angle C, so this is 4. I know side, side, side. Which one do you use? Law of cosines, good. That's the hardest part. Which one do I use? I think on my test I tell you which one to use, but most of the time you don't know. Next, draw a triangle. A, B, kind of a weird triangle, C. Angle B is 21 degrees, so I'm going to put 21 degrees there. Angle C is 102. And little b is 14. Which one am I going to use? Law of sines. Good. Yeah, I'm going to use law of sines because I know an angle, and I don't want to highlight because it's still drying. I have an angle and the side across from it, so I'm going to use law of sines. Next, A, B, C, measure of angle A is 108. 108. Little b is 15. And then little c is 9. Which one am I going to use for this one? Law of cosines, because I have side, angle, side. So let me see, how many of these are law of sines? 1, 2, 3, 4. Good thing law of sines is the easy one. Okay. So let's go through. I may not solve them all today because I don't want to take up all of class time, but I'll at least show you a couple of law of sines. Law of sines says this. If you take this angle and divide it by this side, that equals the sine of whatever you want divided by the side of that. So in other words, if I say sine of 72 degrees divided by the side across from it, and there's 3 ratios you could pick from. So do you think I'm going to pick big C, little c when I don't know either? Or am I going to pick big B, little b when I know one of them? You can't pick 2 pieces of information you don't know and solve an equation unless you had another equation, which is going to be more work. So you're not going to use big C, little c because they didn't tell us either. So you're going to use b and little b. So you're going to say sine of b over 17. Does that make sense? And then you would solve that. And you should know how to solve that, but let me think for a second. I have an idea. Let's just set them all up. That'll be your homework tonight. I'll finish setting all these up. We'll just set them all up, the equation, and then tomorrow we'll solve them all. Does that sound okay? So that's what your homework will be. You'll just set them all up. You'll decide which one to use and set it up, and then I'll check that. Okay, let's do another law of sines. So again, this is not solved. You would keep solving to find sine of b. So let's go to the next law of sines. I would say I would start with what I know. 21 degrees across from 14. So I would say sine of 21 over 14. Equals what? Sine of C, which is 102, right? So I'm going to put sine of 102 over, what's across from 102? Huh? Little c. Yeah, good. And then I can use that equation to solve for little c. And I'll show you that tomorrow. This is going to work way better. I'm glad I made this decision. Let's go to the next law of sines while we're on the roll. What would be my first ratio? Oh, 8 over what? 24 equals might be helpful, maybe, just maybe, if I were to label this. And again, it doesn't matter which one you label, A, B, and C. Let's just do like this, okay? Stick with what we've been doing. So what would that be? Sine of B, because we don't know angle B, over 11. And then you can solve for B, and once you have B, then you can fill in the rest. Number 7, and again, we'll make this be A, B, C. You could have done it in a different order, but let's just stick with that. What would this ratio be? Sine 31 over 41